Now we're going to talk about vectors. So previously we've done vectors in one dimension, but now we're going to kind of do them in a couple dimensions. It'll basically be like solving right triangles if you've done that in trig. So the components of a vector are basically these parts. So this would be the x component, and this would be the y component. And then this would actually be your vector. So this is your vector. It's usually the hypotenuse of the triangle. This is your y component. And this is your x component. And so vector resolution is basically, we can break this vector into the x and y components, and we can figure out how long the x component is and how long the y component is. We can also do the opposite, where we're given an x and a y component, and we figure out the vector. So we'll do both types. If you want to calculate the components, you'll use these two equations, and basically this is going to be your x component. This is your vector right here. And this is the angle of your vector. So when you calculate the components of the vector, ax and ay are going to be the x and the y components. This is going to be the vector, and this is going to be the angle of the vector. Same for this one. Same for this one. Now, this note at the bottom, that's pretty key. When we're doing vectors, okay, sometimes they'll give you something weird. This is your coordinate plane. Sometimes they'll say something like, they'll say like 25 degrees north of west. So then our angle would be, this is our 25 degrees. Now that's not, when you want to get your vectors, this angle is not that 25 degrees. This angle is this one, which is 180 minus 25. So just kind of keep that in mind when you're doing these problems. The angle they give you may not necessarily be the actual angle. You may have to do something like that to change it. Because in this one, we would actually put 155 degrees in for theta, not 25. So in this problem, we have that someone is walking 200 meters at 27 degrees north of east, and we want to find the components. Okay, so we're going to use math to find this. I'm going to go ahead and I'm going to just draw like a little sketch of our vector. It doesn't have to be perfect. So, and then we have, this is north, east, south, west. Never eat sour watermelons. That's what my teachers used, that's how I learned it. So if we have 27 degrees north of east, we're going to go towards the north but above the east. So this is 27 degrees north of east. Okay, so this is 27. And then we also have that this vector is 200 meters long. Okay, so usually I'll go ahead and I will write my components, and I'll write both of them, and then I'll solve for both of them at the same time. So AX is equal to A cosine theta, and AY is equal to A sine theta. So I'm going to put my vector, the length of my vector, which is 200 meters, right here. Now my angle, remember, is counterclockwise from the horizontal. So this 27 degrees is the right angle that they gave us. So we don't have to do any subtraction or anything like that. Now, this is really important. If you are using an iPhone calculator or an iPad calculator, they automatically put it in radians, and I have not figured out how to put it in degrees. So you do not want to use an iPhone or an iPad calculator for these. If you do, you'll get the wrong answer. I did see on the App Store, I was able to find an app for a free graphing calculator, and you can switch that from degrees and radians. So that's an option if you have one, if you have an iPhone or an iPad. So you want to use a regular calculator, or you want to get one that you can swap between degrees and radians. I'm writing this really big. Okay, when you put this in your calculator, you will get 178.2 meters, and then on this one you will get 90.8 meters. Now this part is going to be your y component, so it's going to be this part right here, and this one will be your x component, so it's going to be this part right here. And that's how you solve for the components. Now this is a different one where we solve for components. So we have a crate that weighs 562 newtons, is resting on a plane inclined 30 degrees above the horizontal, and we want to find the components. So in this one, our vector has a length of 562 newtons, and I know newtons is weight, but we're talking about newtons as a vector, so it's inclined 30 degrees above the horizontal. So this is our angle, and the length of this is 562 newtons. And we're going to try and find the y component, and then we will find the x component as well. So now we can solve for the x and the y components. The x component is equal to a cosine theta. And again, you cannot use an iPhone calculator or an iPad calculator with this. You can download a graphing calculator. I found a free graphing calculator. It works fairly well. It's called Free Gra Calc. It shows up like this in my on my app. I think it's the very first one that shows up. It's made by some guy named John or something like that. So if you put this in a calculator that has degrees, you will get 486.71 newtons, and that's going to be this component of your vector. Now if we want to find the y component, we do the same thing but with sine. We do a sine theta. Our a is that 562 newtons, and the sine is 30 degrees. And you end up with 281 newtons. And that's going to be this part right here of your vector.